Okay, everybody. Today we're continuing on the note entitled minimum and maximum of a quadratic function. And we're doing the last two word problems on the last two pages. And I'm not going to sugarcoat it for you. These examples are very difficult. They'll be some of the most difficult word problems that you do all year, and maybe even in all of high school, okay? They're just complicated because you have to come up with a lot of different aspects of the equation, okay? And if you don't pick a good variable at the beginning, that can become very, very difficult. So this also means, though, that it's incredibly rewarding when you do figure it out and you understand it. So I'm hoping that for many of you, this process will all of a sudden click and it will all make sense to you, and then it will become not so difficult if you just think about it in terms of common sense and you have that math background, that understanding of equations that will support your ability to solve these problems. For others for whom this might become a bit more difficult, you may just have to memorize the process that I go through in order to solve this problem. So how I come up with the variable and the different parts of the equation. So if you're headed towards like calculus and vectors next year and something like engineering or medicine in university, you should definitely be the first type of person I talked about. But if you don't plan to pursue mathematics or science or anything, then memorizing is okay. It's not a bad thing to memorize in math sometimes, and often memorizing does lead to deeper understanding. But either way, you do need to understand how to do this type of problem, even if you don't understand why you're doing all of the steps. Okay, so this is a typical type of problem. Sometimes it's pear trees, sometimes it's apple trees, sometimes it's stalks of corn, but it's something that's being planted or something that is causing crowding or something like that. And by changing the amount of trees that are grown or something, that changes the profit or the revenue. So this is very similar to the types of questions where you're driving a bus, where you have a bus company and you want to increase the number of tickets being sold. You want to increase the price of a ticket, but that decreases the amount of people that will take the bus, okay? It's something similar to that. So if you understood those questions, this is kind of a step past that. So there's 100 pear trees being planted as a base. And if that's true, then you get $90 per tree. So notice that it's per tree, not just $90 total, it's per tree. Okay? If more trees are planted, the crowding reduces the pears produced per tree. Okay, so that means there's more trees, and there's more trees total, but the amount of pears on each tree is becoming less and less. So as you plant more trees, you'll have more pears overall until you get to a point where you're planting so many trees that there's so few pears per tree that it doesn't make sense to plant anymore. Okay? That's what's happening. So then the revenue is reduced by 70 cents, okay, per tree for each additional tree you planted. That makes sense that your revenue is reduced because you're reducing the number of pears per tree. Now, so 70 cents for each additional tree, okay? There's a fixed maintenance cost per tree of $7.40 per year. So you're going to have to pay $7.40 per tree, no matter how many trees you plant. That's the amount you're going to have to pay. So how many trees should be planted? Okay, obviously you want to make the most money possible. So this is a revenue profit question. Okay, so first we have to determine all the things we need to know. Okay, what variable are we going to use here? Well, think about this. I said it was similar to those bus questions. Okay, so coming up with a variable is extremely important. We want it to represent the number of additional trees we're planting. We don't want it to represent the number of trees we're planting because that gets confusing. Most of this data is represented, we basically want to know how many extra trees to plant. So we're going to say let X represent the number of additional trees planted. Okay, Okay, now it's possible to make X the number of total trees. It just makes some of the things more complicated. Okay, so it makes for a more seamless problem. Okay, so for you memorizers out there, this is what you should think. Always have your variable be the number of additional things you're doing. Okay, so we're going to need a revenue function. Okay, so let's first think about everything in terms of kind of like an English math hybrid before we put the math together. So the revenue is basically the number of trees we have times the revenue per tree. Right? Because the amount that we're making is per tree. So right now there's 100 trees being planted and we're adding X to the mix. So our number of trees is 100 plus X. Okay? And the amount that we're making per tree, right now it's 90 bucks, but it's being reduced by 70 cents every time we add a tree. Okay, so this 70 cents has to be multiplied by X because that's every tree that we add. Okay, so this is the number of trees times the price per tree. Sorry, there should be equal sign here. So when you FOIL this and collect like terms and rearrange, you get minus 0.7x squared plus 20x plus 9,000. Okay? Take a second, pause the video, make sure you understand this. Okay? Now we're going to do the cost function. So the cost is equal to, well, it's the number of trees times the cost per tree. The cost per tree. Okay, so the number of trees we already decided is 100 plus X. Okay, the cost per tree is where a lot of people end up making a mistake. Okay, a lot of people put 7.40x here. The X should not be there. The maintenance cost is $7.40. The cost per tree is $7.40. Okay? That's being multiplied by the number of trees, okay, which is 100 plus X. If you put another X there, that doesn't make any sense, okay? Then it's saying 740 times the additional number of trees planted times the total number of trees planted. That doesn't make sense. So a lot of people want to put 740x here, but that's not correct. Now a way to think about this is think about it, does the cost per tree change as we add trees? No, it doesn't. So if something doesn't change, then there shouldn't be a variable. The number of trees is changing, so it has a variable. The revenue per trees is changing, so it gets a variable. But the cost per tree does not change, so it should just be a number, a constant number. Okay, so now we're ready to put this together to make our profit. So remember, our profit is just our revenue function. So this is our revenue function here, minus our cost function, which is what this is. Okay, so we write our revenue function, minus 0.7x squared plus 20x plus 9,000. And we subtract this function, which I didn't simplify. You can simplify it up here. This is just 7.40x plus 740. Okay, so 7.4x plus 740. Okay, make sure this is in brackets to show that you're subtracting the entire cost function. Okay, this is another big source of error, is that people don't put this in brackets, and then they end up not distributing that negative. Very, very important step. Okay, so then you just collect like terms, minus 0.7x squared plus 12.6x plus 8,260. Okay, so now we have a profit function in standard form. So to find the vertex, we just do minus b over 2a. And that gives us 9. Okay, So the x value of the vertex of this function, or the number of additional trees planted, that gives us a maximum profit, is 9, okay? Notice that we don't just want to do revenue here, because we're also given costs. So maximizing revenue doesn't mean that we take the most amount of money home at the end of the day once we spend our costs. So we want to make sure that it's profit we're maximizing, not just revenue, okay? So be careful that you check if you're given cost information or not. So how many trees should be planted? 9 additional trees should be planted for a total of 109 trees. Okay, we're going to do one more example. And really watch this as many times as you need to deepen your understanding, because you will be getting questions like this to do. Okay. Okay, so here is a growth problem. And again, in your homework and on assignments and tests, make sure you're comparing what your question is to the examples I did in class, because I chose these examples, again, for a reason. Make sure that you're comparing and contrasting to see which example that Mrs. Weens did is most like the problem I'm currently trying to do. So the more a tree grows, the more it can be sold for. Currently, a 5-meter tall tree is growing 0.5 meters per year. Trees are sold for $25.75 per meter, but that price, due to competition, is decreasing by 30 cents a year. The cost of maintaining a tree is $10 a year. When should the tree be sold? Okay, so notice that when. So that means that we're trying to figure out a time. So your variable should have something to do with time. So I'm going to say let x represent the number of years the tree should grow. Okay, honestly, coming up with your variable is a big part. Like once you've done that, things should fall into place a bit more easily. So this when is a big hint that it should be something time related. Okay, so obviously as a farmer or a tree planter, we want to make the most amount of money. So we have revenue information here and we have cost information here. So it's total profit we want to maximize. So we need to come up with a profit function to maximize. So in order to come up with a profit function, first we need revenue and cost to then put into the profit function. So revenue, how are we making money here? Well, we're making money by our tree. So it's going to be how tall it is, so the height of the tree, times the 25 cents, so the price per meter. Right? That's how we're making our money, is the height times the price per meter. Okay, so it actually isn't the number of years times anything. The price isn't based on how old it is. It's based on how tall it is. And then that, in turn, is based on how long it's been growing. So right now it's 5 meters tall. Okay, and it's growing by 0.5 meters a year. So it's 5 plus 0.5 times the number of years we're letting it grow. Okay? Now, the price per meter right now is 25.75, but it's being reduced by 30 cents for every year that we continue to let it grow. Okay? So here you go. You have to FOIL this, expand it, and collect like terms now. So to do that, you do that, and you get some fancy little thing here. So minus 0.15x squared plus 11.375x plus 128.75. Okay, so that's what you get when you FOIL and collect like terms. So the cost of this tree, it costs $10 per year. Okay, so the cost is just $10 times the number of years. Okay, so our profit, oh, this is our R at X, and this is our C at X. Okay, it's just R at X minus C at X. So when you do that, you still have the negative 0.15x squared. You've taken off this 10x to get plus 1.375x plus 128.75. Okay, so I just did this, because this was only just one term, I just did this in my head, the 11.375x minus the 10x. Okay, so this is your profit function. It's in standard form, so you use negative b over 2a. So x equals minus 1.375 divided by 2 times 0.15 negative, and you get 4.583. Okay, if you're getting a negative number,